Hi, I'm Scott White, the Director of Software Architecture at Tonal. I'm going to talk about how Tonal creates dynamic workouts for our customers. Tonal is a smart home gym that specializes in strength training. The hardware allows software control over the resistance, which allows us to set appropriate weights for each user across different movements. It also collects a wide variety of data that allows us to gauge the performance of the user while they're exercising. We use video to guide the users through their workouts, but we want the video to be as personalized and interactive as possible. We want to emulate the experience a person gets with an in-person personal trainer, but through video and software. We've developed a way to deliver a bespoke, personalized video that is played exactly once on demand. The audio and video are reactive to the user's actions and progress. We can create a video for any workout that gives us a full control over how the video is presented, with capabilities to change that presentation on the fly based on user input. This is what we mean when we say dynamic workout. This process starts with a workout. Most tonal workouts do not have a predetermined video stream for the workout. Instead, we compose a personalized one on demand when the user starts. To create this video, we expand the workout into a contextual outline. Then we expand the outline into a timeline through a media selection process. The timeline gets sent to the Tonal for playback, along with data on all the synchronized application features. I'm going to cover the steps of this process in detail. A workout is a curriculum prescription that consists of a list of sets. A set is a movement plus the prescribed number of reps or a duration, and sets are often grouped into blocks which are repeated in multiple rounds to complete the workout. This means that multiple sets of the same movement are often repeated in the same workout. This isn't something we invented, it's a fundamental feature of all exercise. To improve performance, you have to repeat the same exercise over and over. Here's an example I'm going to use throughout the presentation. Quick Core with Coach Paul consists of a single block with 3 unique sets. Pillar Bridge, also called an elbow plank, for 45 seconds, squat jacks for 30 seconds, and rotational chop for 10 reps. These 3 sets are repeated in 5 rounds for a total of 15 total sets. When the user presses the Start Workout button on Tonal, we take this workout definition and build out a personalized video presentation. The first step in the personalization process is to create an outline for the video presentation. The outline unrolls the workout and includes additional pieces of video outside the workout that we want to include, like warm-ups, cool-downs, workout, block, and movement intros. Outlines can change based on personalization or the workout type. Partner workouts are an example of a feature where we change the outline. It's a feature where 2 users can do a workout together by sharing the tonal. The outline on the left is what we saw on the previous slide. The one on the right is the same workout requested as a partner workout. You notice that we can play most of the video just once for both users. But when we get to rotational chop, we repeat the video for each user since it's not possible for both users to use tonal at once. This allows us to give each user time to get set up and for us to personalize their weights. The next step is to create a timeline from the outline. Tonal's timeline is conceptually similar to timelines you see in standard video editing tools. It contains a list of media clips that represent the final video that will be shown to the user. It also includes metadata that allows us to synchronize application features to the video. We create the timeline by expanding each outline item into a full presentation. I'm going to cover more detail on how we do media selection and how we synchronize application features to that media. We've decoupled the media we present for a workout from the workout itself. We break the media into individual clips and attach metadata called tags that describe the contents of the clip. This means that we have to select the clips that we want to use to present the workout. This process is called media selection. It starts with an outline item, in this case the warm-up. For the warm-up outline item, we search for a piece of media that matches the workout and the type warm-up. The table shows the results of a single clip fitting that criteria.
Hands right behind your head, right knee to right elbow, left knee, left elbow.
Great, that sounds like a warm-up, so we'll insert it into the timeline. This second example for the pillar bridge move intro is a bit more complicated. We've added a tag that matches to pillar bridge, but we still get 5 results, one for each time this move is repeated in the workout. Since we're on the first set, we'll just add a condition for set equals 1, and we get back to a single clip.
Your ISO movement is the pillar bridge.
The outline item has the context about the desired clip, the movement, set number, etc., and we use those to grab a single matching clip to insert into the workout. We can use any number of tag matches to find the correct clip to insert. At this point, you may be wondering why we've taken a perfectly linear video and broken it up just so we can put it back together again. So let's take a look at a more complicated example. Here's how we grab the clips for Pillar Bridge itself. You'll notice we don't include the workout because we reuse move videos across all workouts. We have multiple clips of different types like setup, finish, and action, which is the model performing the move. We also have multiple camera angles. In order to create a video for Pillar Bridge, we're going to follow a plan that includes the setup and finish as we did before. In the middle, we're going to dynamically fill out enough video to match the prescribed duration of 45 seconds. We can do this because the camera angle information allows us to edit these clips the same way a human editor would put them together. We can do this for both time or reps. This allows us to reuse the same movement video within the same workout and across different workouts with different prescriptions. We can also make this edit dynamic by choosing different camera angles each time. We can also be smart and show angles that are more pertinent to a user in the given context, like showing a wide angle for the first clip so it helps the user get into position. The selection process for audio gets more interesting. We want to match the audio to Coach Paul, but again, it's not specific to the workout. We have a large variety of different clips to choose from, like tips or benefits, as well as utility clips like count-ins and time checks. One unique property of audio is that this list grows every content shoot. This means that the quality of the content increases over time as we get more insertion options. Another way we can select audio is based on contextual variables. I mentioned before that the outline item tracks a variety of context. We can tag media with formulas that, when evaluated, allow very specific insertion scenarios.
Just keep going. You're almost there.
As you can hear, we would insert this clip on only the last set. This tagging along with media selection allows us to personalize the audio experience to the user. We have hundreds of available clips to choose from, and we use heuristic algorithms to choose the best clips for the user. In addition to selection, tags are also used for ranking the best clips. We personalize based on the user's workout history, profile information, and workout context. We get many benefits from having reusable media along with our dynamic editing. We can select optimal clips for a given context that allows for personalization and variety. When new content is added to our library, much of it will be available for use across all content. This has the effect that the content is upgraded over time, and the entire content catalog gains incremental value. Of course, we can also cache much of this video, which provides huge network savings. This is especially useful for our device that may be installed in garages or basements like mine with spotty Wi-Fi connectivity. Building the video is only part of the story of our dynamic workouts. Another major component is our synchronized application features. Application and hardware features can be controlled by the timeline progression. Conversely, the UI and hardware can control or change video playback. Both scenarios are controlled by what we call sections. Sections have a placement and time on the timeline, which allows us to synchronize features to the audio or video. In the example below, you can see that we have a section that displays the coach's Twitter handle. Another controls on-screen countdown timer for the warm-up. The set weight section is a hardware section which applies the user's suggested weights for a rotational chop. The image on the right is a snapshot of an in-progress workout. If we zoom in on our HUD, we can see a number of features on screen. We have a button that shows the move demo, the rep goal, the move name, and the set. My prescribed weight for rotational chop has been applied. The progress bar and muscle map are also included. All of these features are controlled by placing the appropriate sections on the timeline. Splitting out control of all the individual features allows us to mix and match across different workout formats and different content. This gives us fine-grained control of feature timing. We can set the wait to the start of the movement introduction or wait until the movement video is showing, wherever it feels most natural. Because the sections are generated on demand, just like the video portion of the timeline, we can change these with server software updates anytime. This means changes can be applied to all content at once to fix issues or add new features. It's verifiable through inspection of the sections in the media, so we can see potential timing or ordering issues visually. It's also extensible. We add new sections whenever we need a new feature. This makes different features independently controllable, and we can mix and match based on context. Clients ignore unknown sections, which allows for backwards compatibility. The older clients can play the rest of the timeline without knowing what to do with an unknown section, so we usually don't have to fork the timeline for new client support. For example, the muscle map was a recent addition to the timeline. The section can be safely sent to older clients, and it will simply be ignored. We control playback and react to hardware feedback using something called triggered sections. These are regular sections with a formula attached where the feature is an action to be performed when the formula becomes true. There are a large variety of hardware and software signals evaluated in real time that we can use to drive these features. In this video, you can see a form detection tip trigger because I failed to pull the rope out all the way. Another common triggered section is our triggered audio. In this example, we've generated a simple timeline that includes audio for an encouragement and a form tip. We've also inserted a trigger to play an audio clip when there are 2 reps left. The formula is true when the rep count is equal to 8 because the original prescription for rotational chop was 10 reps. Since we don't know how fast the user will perform the reps, we have to track the rep count in real time. As you can see, the trigger is true, but if we blindly play the triggered clip, we'll overlap the existing form tip. So we delete that clip and insert the new triggered clip instead. Pacing of the video to the user is very important to allow the user to work out at their own pace. In this example, we have a loop that will show the user how to set up the arms for rotational chop. The loop section will loop forever until the trigger condition is met. In this case, moving the arms into the correct position. When the condition is met, the video will seek to the end of the loop and continue playing. Just to give you a sense of what the final timeline looks like, this is an internal tool that we use to visualize the timeline. You can see the multitude of video clips in the top row with more sparse audio timeline below. The gaps in the audio just correspond to silence. The sections scroll down for another page. We control a large number of application features on every workout. I just wanted to talk a bit about the client player support. The client player is customized specifically to support direct playback of the timeline. We do client-side muxing of the video and audio, so clip timings in our source media require appropriate keyframes, which is supported by our production process. The interface is a single continuous video. This is in contrast to some of the ad insertion technology, which appears with a separate progress bar. The timeline model is a manifest similar to HLS or MPEG-, but tailored to our specific reusability and editing needs. Tonal is an embedded Android device, though the UI is full custom with no direct Android access. We use a custom modified ExoPlayer for playback. ExoPlayer is very extensible, so most of the support for timeline playback plugs into the existing interfaces, but we have made some core modifications to help with more frame-accurate clip muxing and seeking. We have the luxury of a large local cache of about 20 gigabytes. The heavily reused content can be served from the local cache. When not cached, we use progressive download to grab the media. We're a Wi-Fi only device, so everything is currently a fixed 2 megabits HEVC. This probably seems pretty primitive for the Demuxed audience, but the simplicity allows us to focus on the dynamic aspects of the content. We package clips in the standard MP4 with Fast Start. There's probably better options, but it's simple and allows our production team to easily QA the media as it's produced. Because of the flexibility of the overall system, the packaging is more optimized for the production side rather than the delivery side. This approach of personalization differs in a few important ways to how most videos personalize today. Big content sites like YouTube or Netflix optimize for delivery of the same video to as many people as possible. Personalization is limited to choosing the best video from large content libraries. We also do this, but we've taken it a step further. We can pick the best clips and compose a bespoke video composition pulling from everything we know about a user in a fraction of a second. Every individual gets their own experience, even when choosing the same workout. Along with interactivity, this provides our users with a unique and dynamic experience. Thank you. If you want to find out more about Tonal, check out tonal.com.